Now, because this is an equation, and the reason we know it's an equation is because we have the equal sign, it means that we can find the value of the variable. In this case, it's written as an x. Now, when I first teach this to the younger people, I start by writing that. There's generally the whole why do we put letters into maths question. You know that conversation. It's always entertaining. So when they start talking about that, I replace the x with something that they're more familiar with, that box and placeholder, because effectively that's what x is doing. It's holding the place of a particular value, and we need to figure out what that value is. Now, the other thing I would get them to do is to fill in what they know is the answer. Because the thing is, you can actually do a lot of this using your intuition. That says intuition. So, the real thing is, the difficulty is that we have to be able to explain how we get there using calculations. And often we have so much emphasis on the right answer that we've been trained out of showing our calculations. Whereas the answer actually isn't that important anymore. Yes, you get a tick for it when you do it. The calculations are where most of the marks are. So let's go through how this would have been solved. Okay, so the other thing I get the younger ones to do is I tell them that they must write down in words what they've done in each step. And you'll find that the first thing they've done is they've realized that they need to figure out, let's just do some highlighting, they need to figure out what that value is so they can figure out how to get there. And they know that they need to let's get the pen. They need to subtract 7 from 22, and that's going to give us an answer of 15. So they know they've had to do 22 subtract 7 gives them an answer of 15. Then, once they've done that, they figure out that they need to figure out what that is, and to do that, they're going to, it's getting messy, they're going to have to get rid of that 3. How did they get rid of it? Well, intuitively, they knew they had to divide 15 by 3. So let's do that over here. 15 divided by 3 gives you 5. And the reason they did that, and they will tell you, is because 3 times by something will give us an answer of 15. So that means it must be 3 times by 5. Okay, so let's go over the mathematics of that. I had 3x and I added 7. That's the original problem. In order to get rid of that 7, remember over here they needed to figure out what that value was. In order to get rid of that 7, they literally had to get rid of it. They're manipulating the situation because we're adding it. If we just subtract it, look, that's happening there as well. If we just subtract it, then this beautiful thing happens. We've got 3x plus 0. Of course, we don't write the plus 0. Let's go over that again. Where did it come from? We had the 7. We wanted to get rid of it, so we subtracted the 7, and that gave us an answer of 0. But of course, we needed to know that it would be over here 15. And the next step was we needed to figure out what times by 3 would give us 15. And let's actually turn that into 2 steps. So we're going to go rewrite it nicely. 3x is equals to 15. We want to isolate x by getting rid of the 3. over here we can tell that we divided by 3, and so over here we're also going to divide by 3 because that will make it disappear. It'll become x. You remember though that in order to find the value of x we had to divide the 15 by 3, and that gave us an answer of 5. Let's just scroll up just in case it's not recording it. And that is how we would have solved our equation. Now, over the next few years, you're often going to hear the phrase, what we do to the one side, we do to the other. It's personally not my favorite phrase, but it does work. So we're subtracting 7 to get rid of that 7 that's going on over there. Because we want to subtract it on that side to get to 0, we need to subtract it on this side as well. That way we balance the value of this with the value of that. The next thing we need to get rid of in order to isolate x is that 3. And that 3 is multiplying x, which means we need to divide it by divide it by 3 in order to make it kind of disappear. It doesn't really disappear, it just turns into a coefficient of 1, but we don't write it because we are lazy. Now, because we have divided by 3 over here to get to a point where it's just x, it also means we need to divide by 3 over here to get to a value of 5. Once again, you can use that phrase if you want to. What you do to the one side, you have to do to the other. The next question you're going to ask is, why do I need to do this if I know what the answer is? The reason you need to do this is because you are eventually going to get questions that look like this, and you need to be able to solve it. It's not always easy to solve if we don't have the mathematical language to do so. So you would go from there and you'd be able to give me an answer of x is equals to 3 or x is equals to minus 1. But as you can see, there's a whole lot going over here that you need to do to get there, and maybe that doesn't have the same feeling of intuition as before. And that's why at this point we need to master the language of equations, and by language I mean the calculations we show.